Alright, welcome back guys. Today's Friday. Hopefully you have turned in WPR number 19 that was due today. And at this point you should have received WPR number 20 due next Friday. If you have questions on them, remember I'll be here next week to help you guys out. Thanks for sticking with me through these videos. This one's your last one, your last and final one of this week. You'll notice that we're talking about day 5 today, so you're probably wondering where day 4 went. We're just going to kind of swap days and put day 4 on the first day of next week that I see, whether that's Monday or Tuesday. So today is 3/11/16, and we're going to be talking about slope and distance between 2 points because it's going to help us out with something later in this unit. So you can see that there are 2 different formulas here. Distance, or another word for distance is length. We're going to use Pythagorean Theorem, which you guys are very, very familiar with at this point. Then for slope, we're going to use either rise over run or this triangle y, triangle x. Now triangle just means change. Change x, change y means change. And change just means to subtract. So our steps for distance and steps for slope are written out right above here, or right below here, depending on how you're looking at it. And we're going to actually just jump right into an example, and if you need to, you can refer back to this stuff up top here on calculating slope and calculating distance. So the first way that we're going to look at this is graphically, which means that we need to start by plotting points A and B. We have A at -1, +2. And B at 3, 1. And I do want you to connect them because we're finding the distance between them, and so it's going to be helpful to see this using the lines connected or the points connected. So we're going to start by making this big, beautiful table with change x, change y, Pythagorean Theorem, and then change y over change x. So remember, Pythagorean Theorem is our distance and change y over x is our slope. So to find the change x and y, what we're going to do is make a nice triangle, a right triangle on our graph. So I took point A, I dragged it downwards and dragged it over towards point B and made a right triangle. So if we talk about change x, then that's the distance between our x values. So I'm counting horizontally, 1, 2, 3, 4. So change x is 4. Now change y, we're going down 1. So we have a -1 here. Down 1 to the right 4. Notice that I was reading the graph from left to right. Alright, so when we plug in for Pythagorean Theorem, the first value becomes A, the second value becomes B. But when we plug in for A and B, we can ignore the negatives because remember, a negative number squared just turns positive. So we have 4 squared plus 1 squared equals C squared. Type this whole thing in at one time, 4 squared plus 1 squared, and get a number. So we get 17 equals C squared, and then we just have to undo squaring by taking the square root. If you have a nice square root like square root 25, then write down the value. If not, leave it as C equals square root 17. If it's a number that can be broken down, then we're going to break it down. However, this one can't be broken down. There's no perfect square that goes into 17. So we leave our answer as C equals square root 17. Then for the slope, we refer back to change y and change x, and we put y's on top. A way you can think about this is y's to the sky for slope. Y's to the sky for slope. So y's on top, -1, over x is on the bottom, 4. If it can reduce, reduce it. If not, leave it. Alright, we're going to see an example doing this algebraically on the next page. So here we have to find the distance and slope between C and D. So we're still going to make the same exact table, change x, but leave yourself a little bit more space in between. change y, Pythagorean Theorem, and change y to the sky over change x. So remember how I was mentioning that change means to subtract. So I'm going to go back over here and label these as xy, xy. You can even go with x1, y1, x2, y2 if it helps you put these in order. So now I'm going to take my x values and subtract them. 81 minus 83 is negative 2. Take the y values and do the same thing. 4 minus negative 6. That double negative, as you know, turns to positive, so it's really 4 plus 6, which is 10. So now we're just plugging in. I can ignore negatives when I plug into Pythagorean Theorem. 2 squared plus 10 squared equals c squared. Type that right into your calculator. You should end up with 104 equals c squared. We're going to square root both sides, and there is a perfect square that goes into 104, so we're going to break it down. If you forget your perfect squares, let's list them off to the side. 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64. We'll stop there. So now you're thinking or using your calculator and you're saying, okay, 104 divided by 64, is that a nice number? No. 104 divided by 49? No. 104 divided by 36? No. So keep going through this process, typing them in until you find a perfect square and then the non-perfect square that goes with it. Alright, so I found 4, and then 4 times 26 gives us 104. So that means that c is equal to, well, the square root of 4 is 2, and we don't know the square root of 26, so we just leave it. Now for my change y over change x, I go back to my original values of 10 and negative 2. So I have 10 on top, negative 2 on the bottom, and then we reduce it. You can type it right into the calculator. Remember, your calc is really good at reducing fractions. We should end up with negative 5 over 1, or just negative 5. Alright, example 3 here has us determining the distance and slope between P and Q. We can either do this graphically or algebraically. Since there's a graph there, maybe we'll try it graphically. We have negative 5, positive 7. Oops. This point P all the way up here at the top. And Q is negative 5, negative 6. So we're still going to go with our table, change x, change y, Pythagorean Theorem, and change y over change x. So if we think about change in x's, that's left to right. If we look on the graph, our graph is not going left and right at all. It's straight up and down. If we count the change in the y's, straight up and down, you're counting boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So our change in y is 13. That means that the distance is actually a nice distance. So it is 13, but let me show you if you chose to plug into Pythagorean Theorem, how it would work. 0 squared plus 13 squared equals c squared. This gives you 169 equals c squared. Square root, 169 under a radical gives you 13. Okay, so you can do that either graphically or algebraically. Then we have change y over change x. 13 over 0. If you type that in, 13 divided by 0, it's going to give you an error. This is what we talked about yesterday where the slope is undefined. Remember that up and down can be made into that goofy U, undefined. All right, so that's it for your actual notes, but there is a practice problem here that I would like for you to do. I'm going to work through it silently, and then you can check your answers with mine up here on the board as you're working if you get stuck or when you're finished. All right, so as you can see, I found that the distance is 17 and the slope is -8 over 15. On your ticket out, you're going to be working on a couple of problems. There are 2 of them there, just 2, and you're doing both of them. Before we get to the ticket out, though, of course, you're working on either classwork or homework, depending on how much time is left in class. Remember that your homework will be checked on the following class period next week, Monday or Tuesday, when I see you next. Also, don't forget that WPR number 19 is due today. So if you have not yet turned it in, please make sure you turn it into the substitute before you leave here today. Otherwise, it will be counted as a 0 in the grade book before 5 weeks. Remember, I'm doing all of my grading this weekend. So if you didn't turn it in, you're going to be missing out on a test score. If you have questions on this stuff, of course, we can talk next week. I know it's a little tough to follow along with videos. Hopefully it was very similar to me just teaching you guys. But again, if you have questions, then we can follow up next week, either after school or during SAS. Otherwise, have fun doing distance and slope. Just remember to make your tables, and change means to subtract.